Welcome, everyone. We'll get started in about a minute. From those who have just joined, we'll be beginning very shortly. Feel free to introduce yourself in the chat if you like. Mhm. All right. It's 4:30, so we'll go ahead and get started. Welcome, everyone, to the Forward in Energy Forum. We hope you found some place to warm to join our webinar today, wherever that may be around the world. I know our friends on the East Coast are dealing with some record-breaking snowfall, so I hope you all are doing well and keeping safe. My name is Scott Williams. I'm the Education Manager at the Wisconsin Energy Institute, which is the host of the Forward in Energy Forum series. Welcome to those who are returning forum attendees, and if this is your first time joining us for one of our events, we're very glad you're here. For those who are not familiar with the Wisconsin Energy Institute, we are the home of multidisciplinary research, education, and outreach efforts at UW-Madison, and our goal is to provide leadership in those areas to accelerate our transition to clean energy systems and solutions. And so the Forward in Energy Forum is a monthly series that brings together experts both on and off campus for cross-disciplinary dialogue, in which we explore important technical, social, political, and economic dimensions of a wide variety of clean energy innovations and topics. Today's forum focuses on the future of heating and cold climates, and we have a great lineup of both technology and policy experts here to look both at the near term and long term in the future of heating. But before we get to today's session, I just have a few more announcements. First, we want to acknowledge that the land that WEI occupies, as well as all of UW-Madison, is the ancestral home of the Ho-Chunk people, who have called this land Dejok since time immemorial. And we recognize and respect the inherent sovereignty of the Ho-Chunk Nation and the 11 other Native nations within the boundaries of what we now call Wisconsin. And we encourage you all to take time to learn about and support the efforts of tribal nations, both in Wisconsin and beyond, who are leading the transition toward clean and just energy systems. Next, save the date for our next Forward in Energy Forum series. The topic will be March Madness Battle of the Biofuel Crops, and that'll take place on March 24th, again at 4:30 p.m. Central. This is the second year that we're doing a friendly March Madness style competition between 4 bioenergy scientists, and this time we're focusing on sustainable crops for biofuel production. So the brackets have been seeded. So we hope that you join us for fun and interactive sessions where you can vote on which crop will sprout to the top of the competition. Finally, a few logistical notes. We'll have opening remarks from our moderator and panelists, as well as some Q&A with our moderator before taking audience questions. If you have a question at any time for our panel, please submit them in the Q&A box. And you can also upvote any questions that are in the Q&A box that you would like to see addressed. And finally, if you need live captioning in Zoom, you can toggle that feature by clicking on the Show Captions button. And if you have any other technical concerns, please let us know in the chat. And with that, I'll introduce today's moderator. To help us set the stage and moderate our panel today, I'm pleased to introduce Joe Pater, who is the co-director of the Office of Energy Innovation at the Public Service Commission of Wisconsin. Joe has many years of experience working in the energy efficiency industry, both on the program management side and the manufacturing side, as well as starting his own company in data and analytics for utility rebate programs. He joined the PSC in 2020, and in his role as co-director of OEI, he oversees incentives, technical assistance, and energy data, including focus on energy and home energy rebates. So great person to kick us off here. So welcome, Joe.
Thank you, Scott. And I will lead us off here with just a few opening remarks, and then we'll do introduction to the full panel, and then we'll get deep into each of their items that they've brought to this event. So I'll start by saying a few other things to note for the Office of Energy Innovation. Our office provides support and oversight and really day-to-day support of the administrator for Focus on Energy, which is our statewide energy efficiency and renewable energy program that is supported and funded by the utilities in the state of Wisconsin. We would like to just simply make everybody aware that we are currently undergoing a process with our commission to make decisions related to the next quadrennium for Focus on Energy. So if you're interested in any of the work related to planning for what that statewide program looks like, that opportunity will be open to provide comment and just watch the commission process as we prepare for the next 4 years. And then also want to make mention that the home energy rebate program, which originated from the Inflation Reduction Act, it continues to be delivered by Focus on Energy. And our state is fortunate enough to have fully obligated awards from the Department of Energy for the full allocation amount. And we continue to pay rebates for energy efficiency projects, which include insulation, air sealing, heat pump water heaters, heat pumps for heating and cooling, and even electrical upgrades. There's a lot of opportunity, and this is specifically for the residential sector. And there are some income qualifications for certain elements of the program. But the high level message here is that these programs are open for business. They are operating right now, and please spread the word, to the networks that you have. Let folks know that this is a wonderful opportunity to upgrade your home. There's even funding for multifamily residences, and we're just getting started. We just announced that as of February, we've spent $9 million in rebates. Right. I should phrase it as we've paid out $9 million in rebates for over 1,000 projects across the state. Um, and we have close to $150 million to spend. And so, give you a sense of the scale here. There's plenty of opportunity for folks who want to do upgrades. And all of that information is on the Focus on Energy website. You could just simply look for the Home Energy Rebate Program. So I will go ahead and get started here with, we're going to do a brief intro for the whole panel. We're going to start with Mike Hansen, who is the Director of Utilities and Energy Management for the physical plant at UW-Madison. And we're
Yes,
going to
thank
provide a
you.
brief intro and then we'll get into the comments.
Thank you. Yes, I am the Director of Utilities and Energy Management at Madison. I've been with the UW for approximately 7 years and in my current role for 5. In that role, I'm in charge of the heating plants and the distribution networks and the electrical network that provides service to all the buildings on campus. My past, I came from working in construction to working for an engineering firm that designed and engineered utility infrastructure projects for campuses around the nation. And then I transitioned to state service and worked on all types of utility infrastructure projects for all campuses that are within the state of Wisconsin.
Thank you, Mike. And then we have Allison Mavi, Assistant Professor of Mechanical Engineering at UW-Madison. Allison.
Hello, thanks for the intro. My name's Allison Mavi. As Joe mentioned, I'm an assistant professor in mechanical engineering and do a lot of work in energy systems for a lot of different applications. Most relevant to this are related to heat pumps, water heating, different thermal energy systems for buildings. I've done a lot of work in the past in kind of next generation thermal energy systems that have storage in them that can operate at really high temperature lifts, kind of looking at some of the hard applications today of putting in a heat pump system and trying to find a good solution to that.
Thank you, Allison. And then we'll have Lauren Reed, Manager of the Carbon Free Buildings Program at RMI.
Hello, everybody. Good to be here. My name is Lauren Rieg. I lead our Midwest Building Decarbonization Policy team at RMI. We are a techno-economic nonprofit really focused on driving policy on electrification, residential and commercial electrification, and energy efficiency in buildings, with a real focus on economic affordability paired with decarbonization policy. Thank you.
Thank you, Lauren. And then we will go to Andrew Iliff, Policy Director of HEAT.
Hi, everyone. I'm Andrew Iliff. I work at HEAT. HEAT is a thermal energy nonprofit innovation hub. We're based in Boston. Thank you for having me in Madison. HEAT has had a long history working on the kind of thermal energy transition. So initially working on gas leaks detection and mitigation. I spend most of my time now working on thermal energy networks, which I hope to get to speak a little bit about in a little bit more detail, and the kind of gas to geo pathway, which is looking to move municipalities, campuses, residences, everyone from fossil gas to thermal energy, to efficient thermal energy systems. Thanks.
Thank you, Andrew. And we will land with Angela. Angela, I'm going to let you pronounce your last name. You're a professional engineer, lead, associate vice president in decarbonization at Salis O'Brien in here, Madison. Angela.
Thanks, Joe. I'm Angela Pakes, Associate Vice President of Decarbonization at Salis O'Brien, based right here in Madison, Wisconsin. And I'm a 2-degree recipient from U of A Madison and very proud alumni. So great to be here with all of the other panelists today and many of the audience members who are alumni. My career has focused on helping large institutions and communities transition their buildings and infrastructure toward lower carbon, more resilient energy systems. And early in my career at the University of Wisconsin-Madison, I led the development of the UW's first Green Building Standards program from the 2005 Master Plan forward. It was a really exciting time to challenge and lead in sustainable design and construction at the state's flagship university. I was then asked to help co-develop the framework that led to the creation of the university's first Office of Sustainability. Working closely with all the schools and colleges at UW, campus operations and leadership teams shaped how I approach decarbonization today, and that is not as a single project, but as a long-term portfolio of decisions that must align with operations, capital planning, real-world constraints. So today at Salis O'Brien, I lead decarbonization and planning efforts across many higher ed institutions, municipalities, states, and a variety of industrial clients. From our Madison office, I serve as the project manager and technical lead on really complex infrastructure initiatives that we are going to talk about today, including district energy systems and building electrification strategies and geothermal feasibility and implementation and planning. So across my career, my focus has been designing systems that can scale, systems that reduce emissions while remaining reliable, affordable, and adaptable over time, particularly in cold climates like ours. So really excited to be here with the panelists today.
Excellent. Thank you for the introductions here. That's your panelists that are going to be with us for the next hour. Each panelist is going to spend about 5 to 7 minutes with remarks on their specific area of expertise. If you have any questions that you want to post for the panelists, you can add them to the Q&A section within Zoom. And if a panelist has the ability to type out a response, they will. Otherwise, we'll handle it at the end verbally. So we're going to start with Mike. Go ahead, Mike, when you're ready.
All right. Well, thank you very much, Joe. So I am the director at UW-Madison campus, and to give you a little background since this is a nationwide conference, we are a Midwestern campus that's located right in the lower center part of the state of Wisconsin. We have a campus that is approximately 25 million gross square feet of conditioned building space on campus. And on any given day, we will have over 78,000 faculty, staff, and students on campus. So we are our own little city. This beautiful campus has both a rural and a campus feel to it. And one of the key pieces is on the urban side, we do have two major street corridors in the middle which connect downtown and our surrounding campus area. We also have the rural areas do have historical buildings and historical areas within its rolling topography. On the energy side, UW-Madison uses a district energy system for generating steam and chilled water from two centralized production facilities. This district energy service has been used on campus for the last 140 years. The current heating plant configuration has been in operation since 1958, so we do have aging infrastructure. This district system provides efficient, reliable, and resilient heating and cooling to serve all the campus stakeholders in outdoor temperatures ranging from -20 degrees to over 100 degrees with high humidity. And we realized those -20-degree temperatures just a few short weeks ago. Each building is connected to the production facilities via a piping distribution network for steam, chilled water, and electrical. These critical utility services provide heating and cooling to all our major research buildings, along with 4 hospitals and federal institutions that are connected. The heating and cooling production facilities generate steam from natural gas, and the chilled water is either produced from either electric motors or steam turbines. And all the campus building electrical loads are served from our local utility provider through our campus distribution electrical network. Right now, we have campus decarbonization goals, as a lot of campuses are setting right now. And our number one goal is to achieve net zero Scope 1 greenhouse gas emissions from campus plants by 2048 or sooner. Our second goal that we are leaning towards is our procuring of 100% renewable electric by 2030. And this second goal is currently close to being realized. To go to the first goal, we have started an energy study to develop ideas to transition off of natural gas. We are looking at all available technologies, nothing is off the board, to ensure our future energy goal is achieved. With the size, shape, and topography of our campus and the limited growth potential in certain areas, this task will be challenging. UW's energy future, with no natural gas as a primary fuel source, will require some creative solutions, and that's why I'm interested to hear some of the panel's ideas. These solutions will be in the production of the heat energy needed for our buildings. All current technologies are being explored to provide a reliable heat energy to the campus buildings. And right now, this energy can be in the form of steam, hot water, or even electric. If we were to choose a steam solution, that would be the most cost effective, of course, because we could just, I'll call it a plug and play into our current distribution network. This would require upgrades to our production facilities primarily. If we went with a hot water solution, that would require new production facilities and substantial upgrades to the distribution piping networks to each of the buildings and in the mechanical buildings themselves, in the mechanical rooms. If we find an electrical solution, that will require substantial upgrades to the utility network, both on campus and including our local utility provider. The distribution network will need upgrades, and building mechanical and electrical systems will also be upgraded. But any of these solutions will require the production and building systems to be efficient, reliable, and resilient to minimize service interruptions or outages to all of our campus stakeholders. So looking forward to the heat energy for campus, I do not believe, and the study is proving that the campus solution will not be a one-size-fit-all type of approach. There may be different technologies and applications used in different parts of the campus, or even according to building types, whether they're in an academic building or a research building. Another key to success is the ability to keep options open for any future developing technologies, as some of the technologies that are currently being talked about are at the beginning stages of being a viable solution for a smaller production facility that would be required on a campus. So I look forward to this discussion on the future of heating and cold climates, and thank you for letting me do the introduction here.
Thank you, Mike. Okay, we will transition to Allison.
All right, great. Yeah, thanks for the introduction. And I think that kind of situates campus pretty well and where the campus is at. My work is mostly on the research side, looking at new systems. So I'll spend a little bit of time talking about some of the challenges. I think Mike already touched on this a little bit and some of the things that we're trying to look at. And so my lab does a lot of work also in building decarbonization, but looking more at what is not available today and how we can change that. So we have a couple projects going on right now that are looking specifically at heat pumps, some of them for cold climates. So one of the examples is campus has a lot of buildings, and recently we're trying to start leveraging those buildings to do research on these new types of systems. So for example, we have a project coming up that is looking at how do we replace a boiler system in a building with a heat pump. The challenge there is, as Mike mentioned, it can be -20 in Wisconsin. And if you still want to provide hot water to a building at a pretty high temperature, 180 degrees Fahrenheit, that's a really big temperature lift. And so most systems, you can't really take a system today and just stick it in there and expect it to work. And so our project has been looking at how do we take some of these things that are in the lab right now that seem like they have promise, they seem like they work great in at least the laboratory environment, and see, can it really perform in a building? Can it, can we bypass the boiler and just use this heat pump heating system throughout the year, even on that day that's -20? And so I think that makes Wisconsin kind of a nice place to do this work because we do have these really big climate swings throughout the year. And so we can look at systems that are both, a stretch for current heat pump systems, try to really push to get to these really high temperature lifts at, reasonable power levels, try to get efficiencies that are not, efficiencies that are like a coefficient of performance of maybe 2 or above on the coldest day of the year, and then better for the rest of the year. And so that's something that we're looking into now, trying to use campus more as a resource to try new things. I know that they're doing that in a lot of other spaces, and this is just one little example of that. And then another thing that I've been working on is it's going to be really challenging if you rip out all of the natural gas systems and put in entirely like electrified heating systems everywhere. It's just a really big change to how we've been heating, and it takes a lot of electricity to do that. And there's lots of discussion around how we're using electricity anyway. And so one of the projects we're working on is looking at storage and how do you integrate storage into heat pumps. There's lots of different ways to do that. There's actually kind of some good solutions for cold storage in buildings using ice tanks. There's some okay solutions at higher temperatures, but it's a little bit more challenging. And then it's really all built around these large centralized systems, which is great for a place like a campus that has a large centralized system. But actually, most of the floor space in the US is kind of packaged rooftop unit type of systems that don't have the way to easily build in storage. And so that's something that we're working on is how can we get thermal storage into these sort of package systems that hopefully you can just drop on the roof. You don't have to totally rip out the system and design anything. It's just like inherent to the system itself. How do you make it not too heavy to do that? Because it has to go on the roof. And then kind of allow for these thermal storage. You can use lots and lots of different types of materials. You don't need batteries. They don't degrade quite as much. And so trying to leverage some of that in a way that is easy to use. So I guess a lot of the things my lab does is kind of trying to take these technologies, package them into systems, and hopefully have drop-in replacement for things rather than, kind of re-engineering the heating systems of America, because that's a really big lift if you want to try to do it. So, yeah, I'm excited for this conversation. I think a lot of people have very different perspectives than me, so looking forward to hearing what everybody else has to say.
Thank you, Allison. All right, we will go to Lauren.
Thanks, Joe. I was brought on this panel to talk a little bit about the policy landscape and how policy is being designed both within the state of Wisconsin and nationally to serve these technologies that we have talked about and will continue to talk about. But the Midwest is a very fossil fuel reliant region of the nation, and a majority of the buildings are powered by fossil fuels. And so, really the role of policy is to help make that transition, but ensuring that affordability and equity is at the forefront of that transition and to serve, these technologies and the communities that are impacted by it. So although people think about the policy space in a lot of ways, a way that I've been really coming to it and RMI's been coming to it is thinking about affordability and how do we drive decarbonization, the climate movement, decarbonize heating with affordability, because nothing's going to happen if we're going to make bills more expensive for households, for commercial buildings, for industry. And so, I like to think about what is affordability, and that is different to everyone. For a household, that's probably going to be, what do my energy bills look like this month? For a commercial building, it's that, but also, we find commercial buildings are a little bit more focused also on the upfront cost of appliances and upgrades. For regulators, they often have a bigger focus on system-wide costs and looking into the future of if we're going to, build out this data center or build out this natural gas plant or this new solar project. What are the long-term costs and how is that going to impact ratepayers? Legislators are often more focused on taxpayer impacts and, the broader impact to the state as a whole. So although affordability has a lot of different languages, I'm going to kind of focus on what it looks like as a household level, and what people really care about for most homes and businesses are how much is my furnace going to cost me when it dies to replace, and what does my energy bill look like in February after that nasty cold snap. And to think about how policy can serve electrification today, it's really critical to think about where is electrification and decarbonized heating most affordable. And in the Midwest today, that looks like a couple places. Homes with delivered fuels. So if you're on propane or fuel oil, heat pumps can be a really affordable solution, both to lower your energy costs annually. Homes on electric resistance, again, also can really lower the cost because heat pumps are more efficient. And the new construction, where if you're building a new construction building and you do not need to put in the gas infrastructure, which can cost on the scale of $5,000 to $20,000 to put into a building, that can save a lot on upfront costs. And so there are policy mechanisms in place to address getting heat pumps and electrification in homes today. That could look like building energy code policy. So building energy codes are kind of what rules new construction. For example, Oregon just passed, like 2 days ago, they just passed some energy code that encourages heat pumps and all electric buildings in the state and sets the groundwork for supporting new construction, but not mandating that anyone do all electric. Now there's also ways to address kind of upfront and operational costs for people. So thinking about upfront costs, a lot of people are concerned about when their furnace dies, how are they going to come up with the $10,000 to replace that? And there are different strategies that states are taking to address that. Primarily, that looks like incentives and that looks like financing. So, for example, New York, they just passed a bill, and their commissioners are just implementing a new strategy in which they're transitioning some of their incentives away from things that were determined less useful for their residents. Things like lighting or gas appliances that aren't aligned with the goals of the state, or markets that don't need incentives anymore, and transitioning to things that are priorities in the state, like heat pumps, like weatherization, etc. Colorado is working on a bill right now to pass a financing mechanism so that households who want to install appliances would see operating cost savings but struggle with that upfront cost can still afford to put appliances in. Now, there's also a line of policy thinking around operational costs and thinking about how do we ensure that for households today where a heat pump won't lower the cost, are there ways to support people finding or getting electrified heating affordably? And so there's a couple of strategies we're seeing across the country. One is primarily focused on rate design. So electric heating rates is a thing that we've seen across the country. So Illinois and New York and California and Colorado are places that are real leaders on this. And basically what they're doing is taking a look and saying, are heat pump users paying for their fair share of the infrastructure and the cost on their bills? And they're actually finding that heat pump users pay a little more. And so being able to adjust those rates and actually rectify and make sure heat pump users are using the same, like paying for what they deserve and not paying for more of the system, or actually finding that heat pumps become a lot more affordable in a lot of states when that's addressed. So that's one policy line that people are pursuing. Other things are around weatherization, around rooftop solar, and hybrid heating and pairing, making sure that what's being put in a house is affordable and that people have the infrastructure of incentives, of financing, of effective rates, and of the education they need to put that in. And then there's kind of like a third bucket, which is a little bit more forward thinking. I'm sure we'll get into the gas infrastructure conversation. Allison hit on that a little bit. That's a very complex and difficult conversation to have that's being had in a lot of utility commissions right now around how do we design a system that we're driving toward climate aligned and electrification, while also understanding that we have a lot of expensive existing infrastructure out there right now that we frankly are continuing to invest billions of dollars into, even if it's not aligned with the state's energy goals. And considering strategies of long-term policy strategies that can help us meet those goals without leaving households with extremely high bills, or the taxpayers with not having to bail out any of that. So it's a big conversation that I do believe some of the following people will touch on a little bit. So I will pause there and hand it back. Thank you.
Thank you, Lauren. And from here, we will jump to Andrew.
Hi, everyone. I asked for special dispensation from Scott to have some slides because I'm going to try to explain some technology that I work on with as much clarity as possible, and pictures really help. So, but I promise only 3 slides. They won't be too burdensome, hopefully. So the first is, what is geothermal, right? So you've probably heard about geothermal. You maybe think about Iceland and hot lava and power generation. That's not what I'm going to be talking about today. That's awesome if you can get it. It's not available everywhere. So in this graphic you see in front of you on the left, that's that deep geo for geopower. There's also geo direct use, which is using temperature from the subsurface to directly heat and cool buildings. What I want to talk about today is geothermal heating and cooling. So this is relatively shallow, as you see on the picture, 500 feet plus minus. You don't even need to go that deep. If you've got extensive real estate, you can just go like 5 feet or so, get under the frost line and lay they call it a slinky coil. And this is just water-filled piping that is kind of soaking up the temperature of the earth in order to deliver that temperature to a geothermal heat pump or heating and cooling equipment that can produce both heating and cooling. And the thing of that is that so Allison and others spoke earlier about the coefficient of performance of air source heat pumps can really struggle in cold climates, right? Like that's part of what we're here to talk about. They do great work much of the year, but at the very coldest times, they're trying to basically suck temperature out of very, very cold air. And so it takes a lot more electricity to do that. If you're pulling thermal energy, if you're pulling temperature from the subsurface where the temperature is much more stable, your heat pump just doesn't have to work as hard. And that can produce a whole set of benefits that I'm going to talk about, particularly when you connect them together in a geothermal network, which is what you see on the right here. So to recap, the technology I'm going to be talking about, and I'm talking about ambient temperature, so just the temperature of the soil, and particularly connected in a geothermal network. So we can move on to the next slide. Thank you, Scott. So what is a thermal energy network? We think of it as having three main components. There's the buildings. That's what you're looking to heat and cool. That in this setup has a geothermal heat pump in each building. If it's a big building, you might have multiple heat pumps. There are units in New York in Manhattan, where each apartment unit has its own little heat pump. Then you have the distribution system. This is usually lateral pipes, again, like 5 feet under the ground, so just a little bit deeper than gas pipes are usually laid. And I'm going to return to that similarity between gas pipes and geopipes. To move, this is usually a single pipe system. So it's basically one big loop that is moving water around between the boreholes and the buildings, just round and round and round. I mentioned the boreholes. My organization, HEAT, has worked with Eversource Gas on the first utility-owned geothermal network in Framingham, Massachusetts, just down the road. It's now been in operation for coming up on 2 years. It serves around 140 customers. It has 3 bore fields. So the water in that pipe that I mentioned is going down into those bore fields, soaking up the temperature of the earth, and then going back to customers to deliver temperature to their heat pumps. And it's important to note, each element of this technology is old technology, it's very familiar, very well known, been around for decades. The thing that is new is bringing them together in this networked configuration. We like to say that, networking buildings in this way is a little bit like networking computers, that you get these kind of new emergent effects that you didn't see when you just had one computer next to one computer. And part of that, if we can go on to the next slide, is because of the scope to bring in just a really, really broad array of thermal resources. So at the top of this image, you can see you have commercial buildings, residential buildings, municipal buildings. These are where you're like heating and cooling. On the right, there are a set of buildings and infrastructure that you can think of as consuming heat all year. So swimming pools need to be heated, greenhouses. We have a geothermal greenhouse in Boston, and I'm sure you can come up with many others. So then there are ones that are on the bottom that are kind of flexible, that can operate in either mode. Here we're thinking about boreholes, which are great because you can drill them just about anywhere, but you can also use wastewater, sewer systems. You can use bodies of water. And on the left is heat production. This is a really exciting category. These are examples of infrastructure buildings that are rejecting thermal energy year round. And most of the time, most places, they're just rejecting that thermal energy into the air. Off it goes, you never see it again. But so data centers, ice rinks, grocery stores, subway tunnels. But if you can install technology to capture that thermal energy, now you have a thermal resource that you can plug into your network and use to heat your buildings. All right, those are my 3 slides about what the technology is. I'm going to try to move smoothly about why that matters. So at a simple level, what you get when you start to bring together different buildings is you get what's called load diversity, meaning if you have a data center, let's say, and some residential buildings, the residential buildings can just take the thermal energy that is being rejected by that data center. You don't need to generate thermal energy in either place. You're just moving it around from where it's being rejected to where it can be used. This has really interesting effects. So one of the oldest thermal networks of this design that we know of is at Colorado Mesa University. It's been operating for about 15 years. And the way I understand the story is they sort of treated the campus as a living lab. They were like, we're not 100% sure that this will work because we haven't seen it anywhere else, but we think it will work. So they started building. And lo and behold, it worked. They have an interesting climate where they have serious cold, but they also have serious sun. So sometimes they're heating on one side of the building while cooling on the same side of the same building. And this drove the mechanical like resource people crazy. So they wanted to connect it together so you could just move that thermal energy around. Then what happened is that the campus kept growing, but their electrical load stayed steady until eventually their electrical utility, Xcel Energy, called them up and basically said, what is happening over there? And they said, well, we're trying this thing with a thermal network. And Xcel Energy did a study of the thermal network because I think they were worried about like, when is the other shoe going to drop? And what they found is just unprecedented coefficients of performance of this network feature. So in the summer, it's in the sort of 6 range. In the winter coefficient of performance at Colorado Mesa was 8.9, just completely unprecedented. And that's because of this load diversity. So what can we learn from Colorado Mesa? My organization, HEAT, one of the places we focus is on what we call the gas to geo pathway, which is recognizing that, as Allison says, we're going to have to replace infrastructure, but we're also going to have to work with institutions. Gas companies already provide folks with thermal energy that is delivered through pipes. What if they could deliver clean, highly efficient thermal energy using very similar pipes laid by the same workforce and with cost recovered through rates over the same number of decades as gas infrastructure, which is 40, 50 years, depending on where you are. This is particularly important, and this was called out earlier as well, in a place like Massachusetts, where our gas infrastructure is frankly falling apart, and we are spending literally billions of dollars to try to keep it safe. The per mile price of gas pipeline replacement in Boston, where I live, is now around $11 million per mile of pipe, which brings us to the affordability question that Lauren mentioned. So the sticker price of new infrastructure looks high, but you also have to think about the avoided costs of the repairs and replacements that you're doing on existing infrastructure like gas infrastructure. And then the avoided cost of the build out of the electrical system that is required as we electrify heating and the winter peak gets higher and higher as you anticipate a cold snap that might not come this winter. But even if it doesn't come this winter or the next winter, all that electrical infrastructure, generation, transmission, distribution, has to be built out in anticipation, and we as customers have to pay that off through rates. So holding down those winter peaks through efficiency, through high coefficient of performance, that goes into the avoided cost bucket. Now, avoided cost is not easy to get. You can't go to the bank and ask for that as a depositor's check. But it's one of the things that we're seeing emerging in the kind of integrated planning buckets that we're seeing in utility commissions. And we are seeing a lot of interest amongst utilities and commissions. We're at around 13 states that have passed legislation to enable thermal networks in different forms. We have 26 proposed utility pilots in various stages of development. My organization is working with Eversource Gas to build an expansion of that pilot project in Framingham. It should break ground this year with support from the Department of Energy. This is just a really interesting technology for communities, municipalities, campuses, the whole lot. I believe I'm sort of pushing my time, so I'll pause there.
No, that was great, Andrew. Thank you for going that deep for us. And I'm sure there's going to be a few questions at the end here as well on that topic. So, all right, we'll land here with our final speaker, Angela.
Thanks. And I'll kind of stem a little bit based on Andrew's delivery there, and kind of in similar spaces with space and water heating dominating a lot of building energy use in colder climates, as he was mentioning in the Northeast. And that reality really forces us to think beyond single building solutions. My work focuses on how we connect those buildings, technologies, and infrastructure into systems that can actually scale. So that's really relatable to what Andrew was just presenting. And what's exciting right now is that the technologies are no longer the limiting factor. We have mature heat pump technologies, proven geothermal exchange systems, and growing understanding of thermal energy networks. But it's great to see colleagues here on our panel who are also continuing to push the boundaries of those technologies and gain those better coefficient of performance measures. The shift that I'm seeing in our projects is that the question is no longer, does it work? It's just, how do we deploy it in a way that's affordable, phased, and resilient in cold climates? So that shift from technology viability to system design is what really unlocks the scale. One of the most important lessons from our work right now is currently that our district geothermal works best when it's not asked to do everything on day one. So, and I would agree that geothermal should not be the only strategy, which is why I think it's great to have co-panelists like Allison here pushing the boundaries of those technologies. On campuses and mixed-use districts, we consistently find significant simultaneous heating and cooling loads, that opportunities to share between the heating of buildings before touching the ground, even in winter, is a great example. So think of your refrigerator. If you went to go fill your water glass right before the meeting, like I did here, that refrigerator is working hard to keep everything cold, including the water that comes out, even colder on the ice that comes out. But in the back of the refrigerator is, a great source of heat. So similarly, by starting with low temperature hot water networks and using electrified heat pumps, projects can reduce the peak heating demand and shrink the size of the geothermal field need. And that lower upfront costs and borehole risks are reduced, and that reduces your challenges with all the projects as well. So geothermal then becomes a strong strategic asset, not an oversized bet. So we couple the geothermal with other technologies, as mentioned, like the heat pumps, thermal energy networks, and piping. Borrowing wastewater as a source of heat or release is another good strategy that we've been employing recently. Like Lauren touched on policies earlier, and I just wanted to mention that from a policy and utilities perspective, the most scalable systems are the ones that can evolve. And district geothermal systems designed in this way can start very small and integrate incentives more effectively and adapt as buildings then are added and retrofitted to the system. So a lot of engineering decisions either enable policy goals or quietly undermine them. And we want to approach it as a design for phasing, flexibility, and right sizing. So it makes programs and incentives very successful in the real world. So I guess just wrap quickly on takeaways, for communities and institutions that are thinking about cleaner heating now, the takeaway isn't just go build geothermal tomorrow. The takeaway is to start thinking about the district scale. Look for opportunities that reduce your footprint. Look for opportunities that are doing heat sharing opportunities. And then design your systems that don't lock you into one final configuration. Those steps create optionality, and that optionality is what allows clean heating solutions to scale in cold climates. Thank you.
Thank you, Angela. And just a reminder, if you have questions at this point or at any point, please add them to the Q&A. There are a number of them have been added already. And if you are in agreement with asking one of these questions, just give it a thumbs up so we know that that's something that the attendees here want to know. I will get us started with a couple just kind of questions for the panelists. For Mike, you mentioned the energy study that the UW is diving into. Can you give us a sense of timing for that work, and also for stakeholders who might be interested in the outcomes or the work as it progresses? Is there a way for stakeholders to engage with UW on that?
Good question. Our goal is to hit the net zero goal by 2048. So with that said, taking a look at where we are with the study, we have had a lot of engagement from the campus. We have from the campus stakeholders, from students, from the public, and the consulting firm that is currently engaged is compiling all of that information. And we're getting, we're past the midpoint of the study. which then gives us a lot of opportunity to look at the technologies. And I appreciate all the other panelists and sharing what they have experience in, because all those pieces are part of what we are exploring. To Angela's component, it is a matter of scale. We are a very large campus. We have about our maximum cooling load, for example, is 88,000 tons of cooling. So a normal house is about 1.5 tons to 2 tons. So it's a substantial amount. Our electric load is very substantial as well, and we are one of the largest customers for our local utility. So with that said, we are looking forward to try to engage to make sure we have all of these components kind of compartmentalized to be able to understand how we can move forward. The actual study itself, I know it's within the next year. We are going to have it published. How we're going to publish that, I don't know from the project manager side what the concepts are there. But we are exploring all these technologies that have been discussed. Our refrigerant also, that's one component to the heat pumps and how you transfer energy. Those are evolving as well in the new world of technologies. So it's going to be an interesting future. One other thing I will share is that one of the easiest ways to look at our campus is we will not have to decarbonize the energy we do not use. So I made a mention of the gross square footage of our campus is about 25 million gross square feet. In the last 20 years, our campus has grown approximately 20%, while during that same time frame, our energy consumption has decreased by about 30%. So that's a great energy story in itself. And we continually look at ways to optimize either our chill water production, the way that we distribute, insulations, that type of technology within buildings, recommissioning some of our larger buildings so that we are not just taking heat and sending it out in exhaust stack, for example, for some of our lab spaces. So we're trying to find all of those opportunities to minimize the amount of energy that we are consuming so that the cost to be able to decarbonize it goes down just based on scale.
And maybe a follow-up question that one of the attendees posted in the Q&A. Really for any of the panelists who would like to comment on this. What about industrial heat pumps for hospitals, for example, university systems such as UW, but also industry? I know obviously there's a lot of new load coming onto the system. People tend to extrapolate and think, for example, can geothermal handle any of that?
Yeah, I can probably address that one, Joe. As I was saying earlier, what we look at are opportunities. What you want to think about as hospitals, clinics, buildings where you've got multiple buildings is we're looking for ways to network those buildings. As Mike was alluding to, this is a massive campus like UW-Madison. You may not have a big campus like this. So depending where you're looking at, it's still how can you borrow that energy and share that? So you want to look at your coefficient of performance that's been mentioned a couple times. And I think you asked about geothermal. So if you have a coefficient of performance, maybe operating with gas or electric boiler, that's going to be around 1. You want to get higher. And that's the things that Allison's looking into. How can we get higher coefficients? So if you start to look at putting air source heat pumps in, you're going to start getting up in the 2s and 3s. And if you start adding then a geothermal or water source heat pumps, you can now get into 4s and 5s. So you're starting to look at a layered approach with different technologies. But then the real thing that comes in is if you can network your buildings and take advantage of that simultaneous heating and cooling and share that, that's where you're going to get a COP of 6. And that's what you're really driving towards. So hopefully that answers your question.
And maybe I'll just tag on to that. In Toronto Western Hospital, which I believe is a new build hospital, it gets 85+% of its energy load from a wastewater exchange system that was put in. So exactly to Angela's point, right? Like there is some high temp needs, autoclaves and such that have to be served by other infrastructure, but the vast majority of hospitals are incredibly energy intensive, can be met just by drawing thermal energy from wastewater exchange. It's an immense resource. Likewise, operating in a different way in Boston, we have a district energy system, Vicinity Energy, that serves a lot of the downtown, including hospitals, with steam. They are looking to decarbonize their steam system, and in order to do so, they're putting a 6-phase industrial heat pump into the Charles River to draw thermal energy to begin to decarbonize its steam production. And this is again to meet the state's climate mandates.
Thank you, Andrew. And you had made mention of, there's 20 some odd pilot projects happening. Do you, in your experience, do you have a sense of where do these projects, where do they spark? Like, where do they start? Is it the end user? Is it the provider of the equipment? Is it the utility? Like, who starts to push for this locally in
This
your
is a
experience?
great question, and there's not a totally simple answer, I would say. I mean, I think community engagement is an absolutely necessary feature. This is a new, thermal networks are a new technology. People don't, mess about with heating and cooling, heating especially. So they need to be able to trust that this is going to deliver, it's going to keep their families safe and comfortable. And so, this first project in Framingham, the city of Framingham really had an ongoing conversation around municipal sustainability already going. They had a lot of community engagement processes. So when Eversource Gas was looking to figure out where it was going to do its first pilot, Framingham really kind of put up its hand very, clearly. And there's been a lot of collaboration with my organization, with Eversource, and with the city of Framingham. And now there is actually a waiting list to join the existing pilot, and we're getting a lot of interest in the second loop expansion project. So community engagement, I think, is absolutely essential. I think beyond that, sometimes it takes a legal tweak to make it viable. Where are we? About a year and a half ago in Massachusetts, the only organizations that couldn't build thermal networks were the gas utilities. The gas utilities were specifically only authorized to sell gas to customers. In 24, the Massachusetts legislature passed an amendment saying that gas companies could also sell non-combusting thermal energy. So now everyone is sort of on a level playing field. We get a lot of interest from municipalities because they're looking to decarbonize, because they're tired of having their streets torn up for gas pipeline replacements. And I think utilities are a really interesting group, right? Like they're not often naturally inclined to sort of try lots of new things. But I think where they see policy really sort of shifting, where they see that they're going to need a new business model of some sort. This is a really attractive business model. As I said, you can use the same workforce to lay and fuse pipe, which is really important. We're going to be using gas infrastructure for the foreseeable future, and we need a workforce to maintain the safety and integrity of this explosive infrastructure, so long as we're using it. So if the gas companies suddenly go out of business, that's bad for everyone. And so this allows you to have a kind of ambidextrous workforce that can spend part of the month maintaining gas infrastructure and part of the month laying thermal network infrastructure. And I think we're increasingly seeing that recognition in pockets within utilities and in different places, and then also with regulators.
Yeah. And I'll add on to that, Andrew, too. And I agree that a lot of municipalities are looking at this. We're certainly working with a lot of them. We're nationwide, so we see that a lot of states are also driving some additional decarbonization goals, net zero goals, and Mike's very familiar with the state of Wisconsin's goals too. So We are working with many states and municipalities on helping them meet their goals and making their decarbonization plans work. But we're also working with major manufacturers across the country that have their own performance metrics and goals that they want to reduce their energy and greenhouse gas consumption and emissions. So they'll hand in hand energy and GHG together from those strategies and sustainability reports that the companies have is really exciting to see as well. So it's great to see that this is actually not just public sector work, that this is work that's coming from the private, it's coming to the public. And as Andrew mentioned, grassroots efforts too. So we see it all across the board.
Thank you for going deep on that. And maybe I'll pivot us a little bit into the homeowner experience. Or, Lauren, you talked about how the biggest opportunities here are around houses with delivered fuel or electric resistance heating. Like those are just low-hanging fruit opportunities, but yet they're challenging. Many of those homes are rural. Contractors, who are willing to talk about heat pumps may think that is a risky endeavor. They should talk about something more standard, like that element of the contractor being willing to speak of these more efficient technologies also coming with a price. Any best practices or anything that you think we need to know about how to accelerate?
Yeah, absolutely. Thanks, Joe. Yeah, delivered fuel households, those on propane and fuel oil, are often in rural communities. About 15% of the state of Wisconsin's households are on delivered fuels. So it is a significant part of the environment. Especially, we find delivered fuel households particularly prevalent in the Midwest and the Northeast. And they are generally in rural communities. They're generally lower income, so their average income is lower than the state average. And they can be a community that is different to engage with. So a lot of existing programming is targeted at more urban or suburban communities because it has been a historical priority. And also it's a little bit denser. So it is just a little bit easier to engage with. In addition, these households are not necessarily work on big investor-owned utility infrastructure. A lot of them are on co-op or municipal infrastructures, and they don't have gas, so they aren't engaged with any of their gas companies. And so it's really important to think about who is the trusted messenger. And Joe, you hit on it. Contractors are a trusted messenger. Co-ops or municipalities, so their electric utility is a trusted messenger. Local government officials are a trusted messenger. Community organizations or their community action agency are trusted messengers. And so working with trusted messengers to do education and engagement is really critical. Some of the things we've heard from those communities are things like they don't even know what a heat pump is or what their options are. So just educating people on the options. Also, educating people on the benefits. Switching in Wisconsin, switching from a propane system to a heat pump can save you up to $1,000 a year, but it can also add cooling to a home that doesn't have it. And as it's getting hotter and hotter, we're going to need cooling. It also removes the pain in the butt of having to get your propane filled twice a year and do all the math of, okay, so this propane fuel dealer has this price, and then 2 weeks later maybe this is going to go down, and there's a lot of math. And I've talking to people on propane, it is an inconvenient truth of the matter. And so working with contractors and other trusted messengers to help people understand what their options are, what the benefits are, and what their opportunities to help get them access to incentives or financing that they need. To be honest, heat pumps are more expensive if you're going to install than a propane furnace or electric resistance system. And so getting them access to incentives in Wisconsin, the home energy rebates are often a good resource for that, or financing to do that. is a really helpful solution. And that's where policy can come into play. Finding money or setting up programs to educate those stakeholders and those trusted decision makers is a big opportunity. And also setting up the infrastructure to help drive the market and build the market for rural electrification is another way in which policy can drive affordable residential heat pumps.
I would just tag on to that. So, heat pumps, air source heat pumps, ground source heat pumps are awesome solutions to kind of very rural residences and other buildings. One of the things that we think about is like rural town centers, right? That, may or may not have gas service. It can be incredibly expensive to pull a gas line extension to a rural town center, but you don't need a ton of buildings to make a thermal network viable in that situation. One of the reasons we know that is because there is one in West Union, Iowa, that's been in operation, I think now for about a decade. I'll drop the link in the chat. It's part of a great series of stories on Inside Climate News. I highly recommend them all by this reporter. And you get that sort of load diversity and that ability to get cost recovery over time, even at fairly low sort of extent, if you have a little bit of density. So a post office, a general store, and you're in business.
I also wanted to offer one note here. The Energy Innovation Grant Program, which actually stands as the state of Wisconsin's one of the programs here in Wisconsin that seeks to stimulate innovative projects. We just recently opened up a comment period for the scoping of the next round of that program. And because geothermal as a technology has been such a focus of the Department of Energy, and because the commercial tax credits for projects in geothermal still exist, they did not get removed. There is an opportunity to kind of weave that together. And the commission will be reviewing the scoping options for that later this spring. And I will share a link in the chat for those who are interested. But we're open for comment till March 9th. So just want to make sure to put that out there as well. And that's with the Public Service Commission. We do have time for maybe one more question. I know there's some ones in the chat that I think for the most part we've covered. I believe so. And it looks like we might have some written answers to a few of them as well. So maybe what we'll do at this point is give every panelist here a chance to kind of provide one final thought or anecdote on where you see this industry heading and what we can do, to accelerate. Maybe we start with Mike.
Thank you, Joe. One thing I do appreciate about this is, if you think about it, this is a relatively new conversation. Just think, 5 years ago, a lot of these terminology, and discussions were not even being had. I like the fact that we're engaging people in these conversations at every level, whether it's regulatory, government policy, incentivizing through our local energy resources and utilities. It's going to really give us a nice, bright future, I'll call it, for how we're going to look at energy. But we do have to change the paradigm. And yes, I brought up the background of what we have for our large campus type. But from our perspective, our heating solution will most likely be multiple different little pieces scattered throughout the campus. I don't think there's going to be a one size fits all, as I stated earlier. So I look forward to supporting the campus on its journey. And it's going to be interesting to see how all these, not only conversations, but also all the technologies evolve, because we have a district energy system, but it's steam-based. Andrew has done the, idea of all the geothermal style of distribution network. And I look forward to continuing the conversation. I made a mention of our study moving forward and just how we're going to serve all of our heat in these colder areas of the climate. Thank you for the opportunity today.
Lauren?
Yeah, final remarks. I would say I feel really positively about where we are going in the space of decarbonized heating and cooling. I talked a little bit about how affordability is a critical strategy and like must be at the forefront of our thoughts, and to ensure that as we decarbonize and transition our heating and cooling sector to a carbon-free and electric system, it's critical that we do that equitably and fairly, and we are not making it harder for people to heat their homes and cool their homes than it is today. And I think one thing that we touched on lightly, but I am personally excited to see where it goes, is the role of gas infrastructure and electric infrastructure investments, and how we can really think thoughtfully about where do we want to put ratepayer and taxpayer funds into investing. And so, strategies on when does it make sense to decommission? When does it make sense to transition from maybe gas to thermal energy? And where does it make sense to, continue short-term investments in order to drive long-term change? And so that's what I'm interested in learning about and seeing where that part of this conversation goes in the future.
Thank you, Lauren. Andrew?
Yeah, that was really well said, Lauren. I co-sign all of that. I think this conversation, this sort of forward-looking conversation, right? Like we're used to sort of thinking of ourselves in a kind of steady state. We're in a system with infrastructure that works. It's been working, and it really has. Remarkable when you think about how well our energy infrastructure has served us for so long. Now we have to do it differently, and that's like scary and difficult and challenging and also exciting. And I think, in my work, we have what feels like this really unusual opportunity. Like geothermal has bipartisan support. I think that's because of this recognition that it is resilient, it's local, it's independent, it can be affordable. It really like speaks to a lot of things that people of all kinds everywhere care about. And so our challenge is really to kind of harness this moment to really sort of deliver solutions that work for people. And so my kind of parting challenge is we sometimes say, think thermal. You can sometimes see it when you talk to people and they're like, wait a second, that building's heating and that building's cooling. And over here, there's like steam being vented out of the street. Why can't we move it, from my refrigerator in? And I think once you start to think that way, you kind of never go back. And this idea of like being able to move thermal energy from where it's rejected to where it's needed is just immensely powerful. And you can get really creative and fun with it. Like we had talked to a municipality in Boston, outside of Boston, that's planning to build a municipal ice rink right next to a school. And so the conversation is like, what would it take to be able to take the energy from that ice rink to heat the school? And that's really exciting. It's fun to make these challenging environments like interesting and exciting and have a vision for the future. Thanks for having me.
I'll just add on to Andrew because I think it's so exciting. I think we all need to do a project together on this panel, but it's looking at, projects like on campus, ice making to the Kohl Center in LeBron Arena, pumping that waste heat into the pool to heat the pool at the Knicks. So it's just great opportunities like that, and thinking about how we can capture that simultaneous heating and cooling. So technology is no longer the barrier, it's the system design. And just remember that, and looking at the whole as the opportunity, because in climates like Wisconsin, we have to consider both the heating and the cooling, right? So if we start sharing that across those 12 months and looking at electrifying our networks and reducing our peak demands, and then adding in more technologies and layering those in, like the geothermal work, creates the most value as part of an integrated thermal network system, not just a standalone solution, is going to be where we really reduce our risk. And we make it practical and a scalable solution rather than just a one-time thing. So this is really exciting to be a part of that discussion here today with everyone, and I really appreciate my other panelists and all the information that was brought together as a team. So thanks for letting me be here today.
Yeah, this has been great and really ongoing conversation. Many different pathways can be taken and will be taken. So it's the evolution of the technology as well. I think the one thing that gives me, some excitement about it is just that there has been investment into geothermal for many, many years, and there has been an industry for many years working on this back to the 70s. And those industry leaders, like, they're probably reinvigorated by the opportunity that currently sits in front of us. And it's a great moment in time to get people thinking about it, and it's time to think about it. Scott, do you want to close this out?
Yeah, thank you, Joe, and thank you to all our panelists. It was a really great and invigorating discussion. So I'm really excited for where this future leads us. We will be posting this discussion on our YouTube channel. So if you're registered for this, we'll send out a link to that in a few days or possibly a week. There's a couple events that I wanted to highlight. One I forgot to mention at the beginning, but if you want some really hands-on exploration of energy, we've got a great event coming up on March 7th. That's the Renewable Energy Expo, be in the Discovery Building at UW-Madison from 12 to 2:45. And that'll be inside a larger KidWin Challenge competition that we have for elementary through high school students. So hope to see many of you come in and have some hands-on interaction with folks here at UW. And then again, we've got our next forum on March 24th on the Battle of the Biofuel Crops. So again, that'll be an interactive session there. So we'll get a lot of audience participation with that. So thank you all for joining, and we hope to see you at our future events.
Thank you all.